So you're going to be asked sometimes to find the domain of a function. And it's going to be the largest domain possible. So the largest subset of the real numbers for which this function makes sense. So here, I want to find the domain of f of x equals the square root of x plus 3. And so I need x plus 3 to be greater than or equal to 0. Remember, we can take the square root of 0, right? It's just 0. So now I go ahead and solve for x like I normally would. X is greater than or equal to negative 3. And so our domain, we can write one of two ways. I like set notation, usually. So the set of all x such that x is greater than or equal to negative 3. Or we could write it negative 3 to infinity. And I use this square bracket, which I'm going to emphasize a little bit more. I use the square bracket to say that we do have equality at negative 3. Negative 3 is allowed. So now let's go ahead and do the same thing with this new function, g of x equals 1 over x minus 2. Well, here, I'm not allowed to have 0 in the denominator, unless I'm Chuck Norris, but I'm not. And you aren't either, unless you really are, in which case, can I have your autograph? But I want x minus 2 to be non-zero. And once I write that down, I just solve for x again. So I need x to not equal 2. So now I actually have three ways to write this. The first is that set notation, x such that x is not equal to 2. The second is my interval notation, negative infinity to 2, open because I'm not including 2, union 2 to infinity. And we're also always open. We're using parentheses at the negative infinity and infinity because infinity is not a real number. And then finally, we could just do r minus 2. Now this r is the way we write real numbers. That's the set of all real numbers. And then this is a set minus symbol, that guy. So this is another way we can write it. I don't normally use this because you can't use it for square roots as well. But if you like it, go ahead. Now let's try something slightly trickier. Now this is almost the same problem that we had before, right? H of x equals the square root of 4 minus x. So I need 4 minus x to be greater than or equal to 0. And so now I solve for x and I get 4 is greater than or equal to x. Now the set notation doesn't change, x such that x is less than or equal to 4, right? And then the interval notation is now going to start from negative infinity and go up to 4. And it's closed. So that's the answer. Let's try. F of x equals 1 over x squared plus 3x minus 4. So we're going to do exactly what we did before. X squared plus 3x minus 4 is not equal to 0. So now we're going to remember how to solve quadratic equations. We'll factor. So this is going to factor as x plus 4, x minus 1 is non-zero. And now when you have a product equal to 0, you know that one of the two things you're multiplying has to be 0. So either x is, in this case, not equal to 0, or x minus 1 is not equal to 0. So we get x can't be negative 4, and x can't be 1. So how do we write this domain? We can write the set of all x such that x is not equal to negative 4, comma, x is not equal to 1. We could use set interval notation, so negative infinity to negative 4, open, union, negative 4 to 1, union, 1 to infinity. And here it's important that you have negative 4 first and 1 second, right? You can't flip them around. Or finally, you can have r minus the set containing negative 4 and 1. Either of these is fine. So there you go.